Welcome to the second video in our new section of our game developers channel that will be covering Unity. This time we are going to review how to make the player jump, using each of the specific ways to do it, based on the methods we have been using to move them. We will not be jumping using the translate method, because it is the same as some of the other methods. As always, let's review first what we have done in the previous video. We can clearly see how each different method a different impact on how the player is moving and how it can adapt to the obstacles in its way. We can check that the Addforce method works well up to half of the slope. And we can also see how the translate method is avoiding everything, going through all obstacles as if nothing is there. This is because when using translates, we are teleporting the object at very short distances, which means that, in most cases, the collider will not be hitting anything. Before jumping, there are a couple of things that we need to be clear about how jumping takes place in reality, and how, as gamers, we are expecting the jump to happen. When a player jumps, what happens is that it receives an impulse opposite to the gravity that will propel it upwards. The height of the jump will be depending on that impulse and the strength of the gravity. So as the player moves up, the gravity will push it down, up to a point where it will cancel the strength of the up impulse. When the result of the gravity and the force impulse up is 0, we can say that the player has reached the apex of the jump. From there, the gravity will start bringing it down at a constant acceleration. So, while the player is moving up, it will have a positive upward velocity. When reaching the apex, it will have a velocity of 0. And, when going down, it will have a negative velocity. Why are we reinforcing these elements? Because if the player doesn't perform any action, and you let the gravity alone pull down the player, then the jump will feel as floating and not powerful as we usually expect from game characters. This means that, when the player starts to move down, we need to add some extra force to make it falls faster than it should, as to make it feel more like a game jump. In some jump techniques, and based on the animation principles, we could also play with the stretches and squeezes to increase the feeling of a good jump. But we will not be doing this in this video. What do you need for a good jump? First, detect when the player is grounded or not, as to detect if you can jump or not, based on the fact that we are not trying to make double jumps. The second thing is that we need to detect the change of phase of the upward velocity and detect the frame where there is a shift between positive to negative. When this happens, we are at the apex, and from now then, we can apply the extra boost force to make the player fall faster to the ground. All these steps will be more or less easy, depending on the method, but we will try to implement it with all the methods that we have seen in the previous video to move the character. Let's go now to the actual jump, and starting with the character controller. The ground detection comes already within the methods made available by the character controller component. So, let's check if we are pressing the jump button, which in our case will be the space button. If true, then let's add an upward velocity to the movement direction vector defined. Let's name it jump speed, and let's initialize it with the value 12, which is bigger than the gravity, as to make sure that we can have a generous jump. We don't need to do anything else, because the character controller and the functions defined in the previous video will handle the gravity. Let's run it. We can see that we can jump quite high due to the intensity of the jump speed. But we can also see the floaty behavior that we discussed early on. Although the gravity is pulling down the object in a realistic way, the feeling that we get is that it is floating down. So, let's try to solve this. For this, we will need some extra variables that will sum parameters of the jump. In this case, to know that we are jumping, creating a Boolean variable, is jumping, that will set to 1 the jump is started. We will also need to clean the code, by putting all the related jump instructions within a new function called jump. Now, before actually making the player move up with the jump, we need to check if we are jumping and the value or vertical speed is positive, then this means that we are still moving up with the impulse of the jump. If not, then this means that we are falling back to the ground, and it would be good to apply a multiplier that will make the object move faster towards the ground. Let's run it, to see if works. No. It is not jumping. Let's go back to the code. Okay, we made a couple mistakes in the conditions for the jump. We only need to apply the force if we are not already jumping. And in the same way, only apply the force multiplier down, if we are actually jumping. Let's clean the code, and let's move these instructions inside a new function called apply gravity. But, on second thoughts, the apply gravity code seems to be wrong. Because if we think correctly, the gravity should always be applied to the object, and not only when jumping or falling from a jump. Let's fix it to make sure that the gravity is always applied. Let's quickly try it. We can see that the object falls faster toward the ground now. Time to implement the jump on the player character using the rigid body velocity. Since we relied upon the rigid body gravity, we didn't need to check if the rigid body was grounded or not. Now, to be able to jump, we need to check if grounded. The best way is to copy the different function that we had developed in the previous video, for the translate method, and implement it in the rigid body velocity method. The first thing is to only jump if the player is grounded. This check will make it impossible to jump an infinite number of times. So, let's move the function jump below a condition check on if the player is grounded. Since the variable doesn't exist, we need to create it. Let's copy from the translate method, the ground checking spherecast to its function that we will call check is grounded, and let's save the result to is grounded. We will need also to provide an object as the origin of the sphere cast. It will make it easier to place under the player. We need also the jump speed variable that will set how high we can jump. Let's change move the checking F if the player is grounded to be directly inside the jumping function. Finally, let's change the jump function and to perform the jump to right height based on adding a new vertical speed to the player. Let's go back to the scene view, and create a new empty object to mark the position where the sphere cast has to be originated. Let's run the game. We can see that we jump less than with the character controller. We can improve it by moving the apply gravity function from the update method to the fixed update, which is the best place to run it. But now, if we run it, the player goes through the ground. This is because we are still applying gravity to the rigid body even when he has already landed. So, let's create a new condition in the apply gravity to set the velocity and y to 0 as soon as we touch the ground. Let's test it again. And now it stops correctly. We can still improve further the function by taking in consideration layer, and that will allow us to check only for a specific set of objects. So for example, to stop when touching the ground but not stopping when landing on an enemy. For that, let's create a new layer ground by clicking on the top right drop-down interface layers. Type in ground in one of the empty slots. Reselect the game objects that you want to associate with the layer and set it in the layer interface. Now, let's go back to the scripts, and add a new public layer mask variable named mask. Let's pass its reference in the spherecast function, and then let's go back to the scene view and select the ground layer under the player script. Now, it's time to go to the rigid body jumping using forces. The code that we need to implement is basically the same then for the velocity. The only difference is that when jumping, we will apply a vertical force, then actually changing the vertical speed of the player. We will fast forward up to the changes that are actually different. So, in the jump, you can see that we are changing the vertical speed of the rigid body, so now, we have to replace it by an Addforce that will apply a vertical force to the player, that we can achieve by multiplying the jump speed with the vector up. For the force mode, we will use the impulse mode, as we want something that will happen fast and once. Let's add also a condition to make sure that we are not already on jump. Let's fine-tune the parameters in the inspector and let's run it. Not bad at all. Almost as similar than the character controller. Now, let's try to implement it with the move_position of the rigid body, in the script that we have defined in last video. Again, the function is very similar to the previous ones, so we can copy and modify the function to use the move_position method, rather than the velocity or the add force. Again, let's speed up the video up to the point where the most important changes will be done in the apply gravity and jump function, because we will have just to change the operation on the movement direction vector. Well, this last method is apparently jumping less, but it is a question of fine-tuning further the parameters. You can test it to try to find value of the jump speed and force multiplier that will work correctly for you, in case you want to use this move position method. We will not perform the changes in the movement based on the translate weaken that all the jumps are very similar, and from a movement point of view, the translate has a lot of problems. In the next episode, we will start to bring some animations. Since in the between, we have also started a Flax Engine series, we will try to bring them on the same level and to progress in parallel with them as allow for a good comparison between the engines. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.